Hope you can see me and hear me clearly. The video system works with a lag. So I start speaking and then it goes through some systems and then comes on YouTube. So there's going to be a 30-second lag. So for the first 30 seconds, I'm just going to stand and look at you guys, say hi, hello, and wait for somebody to comment saying, hey, things are fine. You can see me and hear me clearly. Then we'll jump into the class. Okay? We're going to do a bunch of interesting questions as always. Some of these are slightly simpler than what you have seen the previous week. These are for the levels for class 5 and 6. Anyone can try this, they're not that easy. If you're in class 7 or class 8, you can still try it. If you're in class 4, you can still try it. What's the harm? You may get some things wrong, that's all right. Fine. So I'm just waiting for some comments from somebody. I think Harsh Vora has already commented saying, please start. I want somebody to say, hey, we can see you and hear you clearly. Once the audio video feed is done and dusted, then we'll start with the class. And so I hope you guys have done the tried the last 2 weeks classes. If you have not tried joining in for this week alone, just go down to the channel. You'll be able to see the previous 2 classes. Please try them out and try solving the questions. The questions are also on downloadable format on the website. Check out the description of this video. You'll be able to see where you can download the question, where you can access the questions. Simple rule of thumb, try the questions and then solve and then go through the video. Once again, I'm waiting for some comment from someone. I think Harsh Vora, Gautam are there. We can see and hear clearly. Wonderful. And with that, we'll sign off and run through this. Oops. Square papers of black and white are arranged as shown. Totally 80 squares. The number of white squares is a very interesting question. I like these questions because you don't need any Bhayankar math to solve it. Just think about it, you apply yourself, you can get the answer. If you've done 3rd standard, 4th standard level, you can answer this question. Fine, so let's try this one. So there's some pattern sitting there. First step for us is to find the pattern. 2 black squares, 2 white square, 1 black square, 1 white square, 2 black squares, 2 white square, 1 black, 1 white, 2, 2, 1, 1. And the moment you find the pattern, it's important to just verify if it's the whole pattern. So 2, 2, 1, 1, 2, 2, 1, 1, 2, 2, 1, 1, etc., etc. Now the next step is to say, okay, at what cycle does my pattern end? So pattern gets cut off here, the pattern gets cut off here. Every 6 squares, the pattern gets completed. What happens from 1 to 6 happens from 7 to 12, happens from 13 to 18, happens from 19 to 24. Every set of 6 symmetric. Lovely. Now if 80, this number is what we need to find. This number had been 60, the multiple of 6, life is very easy. Done. Everything will behave, there will be 10 sets of 6, we're done. No, that's not. Now what you have to say? We have to say sets of 6 will collect. So in the first 6, if you think about, there will be 3 black and 3 white. We took about the first 12, there will be 6 black and 6 white. First 18 will be 9 black, 9 white. So any multiple of 6, this question becomes very easy. First 60, easy. First 66, easy. 72, easy. 78, easy. 84, I don't want to do 84. I'll do till 78. I'm going to think about the first 78 squares. This is 13 sets of 6 each. In each 6, there are 3 blacks and 3 whites. 13 into 3, 39 blacks and 39 whites. Lovely. So we completed 13 cycles quite wonderfully. All done. Now, but that means we've gone till square number 78. 79 and 80. Many. 79 and 80. So the number of white squares we need to find. Till 78, there are 39 black and 39 white. Now 79th square will be back to this beginning. So this will be the 79th square. This will be the 80th square. Or from 78 onwards, the 79th square is a black one, 80th square is a black one. Or there will be totally 41 black and 39 whites when there are 80 squares. Okay. Go in steps of 6, grab 6 at a row, complete that, and then think about what is remaining. So if you're looking at 80 squares, it is 13 sets of 6 squares each. That will break as 39 and 39. After that, there are 2 black squares, 79th and 80th. The question says how many white squares Quite a simple routine question actually. Just figure out the pattern and then we are good to go. Lovely. So I'm going to go to the next one. Try this. Good question. I'm just having a look at the chat. Wonderful. Nothing funny in the chat so far. Right? When 26 is divided by a positive integer n, the remainder is 2. Wonderful. One of my favorite questions because this takes you through a beautiful funda with the very nature of divisor, dividend, remainder, quotient, all of that. It's a beautiful question. 26 is divided by a positive integer n, the remainder is 2. So 26 divided by n, the sum quotient, something comes here, in the end the remainder is 2. Remainder by definition is linked to what remains. We divide 26 by n and we say, look, how many times can n go and sit inside 26? And then it sits a certain number of times, then something is remaining. Whatever is remaining is remainder. How many times does 26 sit inside n? It sits inside n quotient times. Or the other way of thinking about it, into 26, I put n quotient number of times. Right? So it might add up to something, but something still remains. It is not going completely inside. What remains is called the remainder. Lovely. So this is the very definition of the idea of reminders. Write it down somewhere. Write it down on a big sheet of white paper. Stick it in your room where you study. Write it down in your math notebook. Very crucial thing. It's a fundamental property that's going to chase you throughout. Any number is a divisor into quotient plus remainder. Divide 26 by n, you get remainder of r, quotient of q. 26 is n into q plus r. So the remainder is 2. What does that mean logically? You divide 26 by n and 2 remains, or this n goes some number of times to account for 24. 2 remains from 26. You remove this 2, 24 can be accounted for. Or n into q is 24. Lovely. This question says the sum of all possible values of n. That means there are several possible values of n. We want to find all of them and then we want to add all of them. We are not solving for one n. We want to find all possible values of n. You divide by n, you get a remainder of 2. We know that n into q is 24. A multiple of n is 24, or n is a factor of 24. Life is simple. N is a factor of 24. Now we know how to approach this question. So I'm going to write down factors of 24. 24 can be written as 1 into 24. 1 and 24 are factors. Can be written as 2 into 12. 2 and 12 are factors. Can be written as 3 into 8. 3 and 8 are factors. Written as 4 into 6. 4 and 6 are factors. After that, we'll come back to 6 into 4, 8 into 3. These are all factors. Or n could take any of these values. If n is 1, q is 24. If n is 2, q is 12. If n is 3, q is 8. If n is 12, q is 2. Any of these values n can take. Could n take all of these values? Think about it. If n were 1, I divide 26 by 1, I won't get a remainder of 2. 1 is a factor of any number. So I get a remainder of 2. That means my divisor n should be strictly greater than 2. I divide by 2, I can get only 0 and 1 as reminders. I divide by 3, I can get only 0, 1, 2 as reminders. Whatever the remainder is, my number n should be greater than that. Or n can be any of these, but it cannot be this, it cannot be this. It cannot be 1 or 2. You divide by n and you get a remainder of 2. That means n is more than 2. That means n can take 3, 4, 6, 8, 12, 24, but not 1 and 2. First step is to identify that n is a factor of 24. Then think about factors of 24 and then say in this list of factors of 24, I'm not going to count 1 and 2. Right? Now how do we add this? 12 plus 8 is 20, 20 plus 24, 44, 50, 54, 57. Adding all of this, we get 57. Or sum of all possible values of n is 57. If any of you has got the answer as 60, then that means you have counted 1 and 2. You should be wary of that. You should say, look, I shouldn't be counting 1 and 2. I'm getting the remainder as 2. So my divisor has to be more than 2. Keep that in mind. Fine. Lovely. Wonderful. Let's jump and do the next one. Read this one, slightly longer question. So I'm going to give you some time to read it, then we'll attack it. The first iteration when you're doing these questions, don't be in a hurry. Make sure you get the funda right, you get the detail right, you verify that the answer is correct, all of that. With more practice, you can reach a point where you're saying, hey, I can do this even quicker. You can find the juicier methods. You get there, but initially the idea is to get everything correct. It doesn't matter how much time you take. In a garden, there are 2 plants. One plant is 44 centimeters tall and the other is 80 centimeters tall. 44 centimeters tall. One is 80 centimeters tall. Lovely. The first plant grows 3 centimeters every 2 months. 3. Every 2 months it grows 3 centimeters. Second one goes 5 centimeters every 6 months. 5. But every 6 months. The number of months after which the 2 plants will have equal height is, when will they have equal height? And so this is 5, this is 2, this is 3 centimeters, but it's 3 centimeters every 2 months. That is 5 centimeters every 6 months. First thing to do, I'm comparing these two. I'm going to think about the same set of time. How much time I'm having for some growth here, the same time I'll count here. This is every 6 months, this is every 2 months. If I have 3 sets of 2 months, that will account for 6 months. So first of all, I'm going to say 3 sets of 2 months. In 6 months, what happens? In 6 months, this grows 9 centimeters, whereas this grows only 5 centimeters. Lovely. The first thing we have done is to say what equal units of time, what is happening. So in 6 month duration, this grows by 9, that grows only by 5. Brilliant. This is growing faster, so this will catch up with that. After however long it might be, this will catch up with that, because whatever be this deficit, it will grab on because it's going faster. It's like saying somebody who's slower than you, somebody who drives at 40 kilometers per hour and wants to go from Bombay to Pune has left. You travel at 60 kilometers per hour. Then you don't just go from Bombay to Pune, you go from Bombay to Pune and then keep on traveling. But even if the person leaves half an hour, 1 hour, 2 hours earlier, as long as there's a long enough distance for you to catch up, you will catch up. You're quicker and you'll catch up. Now, the idea of catch up, I want to think very differently. Every 6 months, this grows 9 centimeters. Every 6 months, it goes 5 centimeters. So, in a 6 month period, think about how much this plant will catch up with this plant. How much will it gain? How much more does it grow? How much does it shrink the difference by? Find any way you can think about this. This grows by 9, that grows by 5, or in a 6 month spell, the difference is 4 centimeters. Difference I'm going to call as delta. So every 6 months, this one gains 4 centimeters. And so this grows 4 centimeters more than that one. And now I'm not going to worry about each step. I'm going to worry only about the difference between these two. The starting point here is 80. Starting point here is 44, or the difference between these two is 80 minus 44. What is 80 minus 44? 80 minus 40 is 40, 80 minus 44 is 36. The difference between these two is 36 centimeters. This is the 36 centimeters. This shorter plant but faster growing plant has to catch up. It catches up 4 centimeters every 6 months. How long will it take? 4, 4, 4, 4, 4, 4, keep on adding. When will we hit 36? In 9 sets we'll reach 36, or 9 into 6 months. We'll catch up. 9 into 6 is 54 months. I'm going to do a very quick recap and introduce you to one more idea. 54 months is our answer. What do we do? I'm just going to cross check this. So One plant starts at 44, another plant starts at 80. Every 2 months this grows 3 centimeters. So this is 54 months or 27 sets of 2 months. This grows 54 centimeters or 9 sets of 6 months. So in this case, 24 sets of 2 months. Each 2 months there will be a 3 centimeter growth. 27 into 3, 81 centimeters this grows. 9 into 5 equals 45 centimeters this grows. Or this will have a height of 125 centimeters. This will have a height of 44 plus 81, which again is 125 centimeters. In this case, these two perfectly match. It's a nice comparable set of. This is also the difference is 54 months, which is a multiple of 6 months. It's also a multiple of 2 months. Life is easy. But the questions were different. The numbers did not perfectly match. Then you'll have to count out in terms of the steps of 6 months, reach one point. After that, go step by step. Go 2 months, 2 months, 2 months, 6 months, and then methodically see where you'll go, because they're not growing uniformly. This goes in steps of 2 months, then goes in steps of 6 months. If that's how you've been given the data. In this case, 9 complete cycles, life works brilliantly. At the end of 9 complete cycles, this plant will be 125 centimeter tall. So too will this plant, or the difference of 36 centimeters has been caught up by the originally shorter plant in 9 cycles of 6 months each, or 54 months. The number of months after which the two plants will have equal height is 54. Lovely. A standard question, routine question, you should be able to knock it off. Give it a try, we'll discuss this. Lovely. I'm just looking at the chat window for the previous question. Be very careful. Do not, when you're listing out factors, don't miss out anything. So you can't afford to forget 24. And you have to leave out 1 and 2. Both are important. You should not count 1 and 2. You should count 24. Keep both of those in mind. Right? And whenever you get the answer or method or something interesting, at the time you're not intentionally solving, then do post on the chat. Right? If you multiply 2 by itself repeatedly 4 times, we get 2 into 2 into 2 into 2, 16. This is technicality. This is called 2 raised to the power 4 is 16. 2 raised to the power 5 is 32. 2 raised to the power 6, 64. When I was younger, this used to be a very favorite hobby of mine. Multiply by 2, then know all the powers. 2 raised to the power 10 is 1024. And so 2 power 10 is 1024. If you're a mathematician, 1000 is not a round number. This is a special number. And so 2 raised to the power 20, those of you who are interested should try. These are special numbers. The powers of 2. You multiply by 2, you get new numbers. You should try it out. You should keep on multiplying and you should find that. Right? Lovely. So we're going to stop doing this. And quite obviously, we cannot do this. When we're very passionate about numbers, but we cannot sit and find this. That's not happening. 2 raised to the power 2021. That's not happening. It's not happening in this week. We keep multiplying. And so 2 raised to the power 2021. How do I do that? So anytime you're given such a large number, you should say, look, 2 power 2021 I can't find. 2 power 1, 2 square, 2 cube, that I can find. Let me find what I can find, then we'll go from there. So I'm going to think about that. We're worried about the units digit of B. We don't care about the number itself. Obviously, the number is going to be a very large number. It will be probably 600 digits or 700 digits, a very large number. Right? But we're worried only about the unit digit. So I want to think about 2 power 1, unit digit is 2. 2 square, unit digit is 4. 2 cube, unit digit is 8. 2 power 4, 2 power 1 is 2. 2 square is 4. 2 cube is 8. So far, the number has only one digit. Number has only one digit, so life is easy. 2 power 4 is 16. It ends with 6. 2 power 5 is 32. That ends in 2. 2 power 6 is 64. That ends in 4. 2 power 7 is 128. That ends in 8. 2 power 9 I've gone this far, I can't think about these numbers. So I'm going to write it as 128 into 2 and find out. 2 into 8, 16, 6. I don't care about the whole number. Now think about it. 2 power 10. I don't need to know 2 power 9. I know it ends in 6. You multiply by 2. 2 into 6, 12. This will end in 2. 2 power 11. This into 2. This will end in 4. 2 power 12. This into 2. This will end in 8. So each number, you take the unit digit of the previous number, multiply by 2. If you have some carryover, forget the carryover. Think about a unit digit. That's how the pattern is. That's how this behaves. Now let's look at these numbers. This 2, 4, 8, 6, 2, 4, 8, 6, 2, 4. See if there is something here. What is the pattern we observe? All of these are even numbers. Obviously, a power of 2 cannot be odd. None of these, even in even numbers, we have only 2, 4, 6, 8 coming. It cannot end in 0. Why can anything not end in 0? Ends in 0, it has to be a multiple of 5 also. It's only a power of 2. It has going to end only in 2, 4, 6 or 8. Within that, 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. It's a very simple pattern. 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. Very simple pattern sitting there. So 2 power, sorry, this is 2 power 8. I made a mistake with the number. This is 2 power 8, 2 power 9, 2 power 10, 2 power 11, 2 power 12. So the pattern is very simple. 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. Now we need to find, when you are having a pattern like this, where will we have 2 power 2021? This pattern comes in steps of 4. 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6 and so on. Or if I write this down slightly differently, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8, 2 power 9, 2 power 10, 2 power 11, 2 power 12. This will be 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6, or all of these will be 2, 4, 8, 6. Right? All you've got to now find out is we keep on writing numbers in steps of 4. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Where will 2021 sit? This goes in steps of 4. So the easiest thing to measure or keep track of is this number. It's 2 power 4, 2 power 8, 2 power 12. Think about this. 2 power 16 will be here. 2 power 20 will be here. 2 power 24 will be here. 2 power 28 will be here. 2 power 100 will be here. 2 power 1000 will be here. Why? Any multiple of 4 will be there. Now we've got on to something. We want to find 2 power 2021, 2021. We know if we get multiple of 4, we are close. So let's find a multiple of 4 very close to 2021. So 2 power 2000 is a multiple of 4. 2 power 2020 is a multiple of 4. Or 2 power 2020 will be here. 2 power 2020 will end in 6. 2021. Next cycle will begin, it will end in 2. Or the units digit of B, 2. Remember this, anytime you have any of these power question, any number, any power, when you're taking any reminder, or any time you're tracking units digit, just think about one thing, there will always be a pattern. First step, find the pattern. Then you think about where do I sit in this pattern? I know this goes in steps of 4. It's ABCD, 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 endlessly. Now, where is my 2021 going to sit? That's all you have to think about. Then you methodically think in terms of every power, every multiple of 4 sits here. Locate the closest multiple of 4. Then think about the number itself. Lovely. Again, it's one of my favorite questions. It's a beautiful question. So I'm going to give you some time. Try this question and we'll have a go. I think we're doing okay on speed. Maybe we'll increase the speed. Lovely question. I like all kind of questions where you don't need to know anything beforehand. No prior knowledge required. Do this question, you can give it to an 8-year-old, 9-year-old, they can try. It is tougher for them because they're not comfortable. They might not be able to read 9, 91, 98, 911, 191. They might not be able to read and grasp numbers that quickly. But they don't need to understand ratio and fraction and angle bisector and all of that. They just simply observe the pattern, see what is happening, then you are good. And so there is some pattern observing that you have to observe, and there is some way this is given. It took me a while to even understand what the pattern was. And so very interesting pattern. First one is 9, then 9119, 911, 191, 119. So that's 1-digit number, 2-digit numbers, 3-digit numbers, then 4-digit numbers, and so on. We're listing all of these numbers have only 9 and 1 in them. And then in 3-digit numbers, if you notice, it is 911, 191, 119. It's like the 9 moves from one digit to another quite brilliantly. And so I'm going to write it down slightly differently. I start with 9, my first number. Second number is 91, third number is 19. And then I have 911, 191, 119. What happens? I have 1-digit number, 9, done. Second digit number, I have 9 and 1. I put 9 and 1. I have the 9 in the first digit, it moves to the second digit. Then I put 911. Then starting from the first digit, the 9 goes to the second digit, then goes to the third digit. A 4-digit number be 9111, 1911, 1191, 1119. Now we've got the pattern. Then we'll have 5-digit numbers, 6-digit numbers, 7-digit numbers, 8-digit numbers, and so on. How many 3-digit numbers are there? 3. Why 3? Because 9 could be in the first portion, second portion, third portion. How many 4-digit numbers will be there? 4. First, second, third, fourth. How many 14-digit numbers will be there? 14. 9 will go from first digit all the way till 14th digit. Lovely. Now let's think about this. We want to find the 45th term of this sequence. Brilliant. So on all of these questions, I like counting till the end of each row. So the first row, you're one number down. Second row, 1 plus 2, 3. Also 1 plus 2. Third row, 1 plus 2 plus 3, 6. 1 plus 2 plus 3. So end of the third row, we have accounted for 6 numbers. This is a 6th number. What is this? This is a 10th number. Why 10th number? This is 1 plus 2 plus 3 plus 4. What will be the last number here? That will be 15th number. Why 15th number? 1 plus 2 plus 3 plus 4 plus 5. Lovely. Now I'm going to jump. I've got the method. So at the end of row 1, I'm in the first number. End of row 2, I'm at number 3. End of number 3. End of row 3, 6. Row 4, 10. Row 5, 15. End of row 6, 21. End of row 7, 28. What am I doing? This plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. These numbers are called something. 1, 3, 6, 10, 15, 21, 28. They are called something. I wanted to find out what they are called. And so what are they? What are they called? Find out. Find it out. Row 8, 36. I keep on doing like this. Somewhere I should be able to get to the 45. End of row 9, 45. Lovely. We've got 45 straight away. Plus 8 plus 9. Or the row 9 ends with the 45th number. Row 9 is all a bunch of 9-digit numbers, all having only 9 ones, only 1 9, several ones, remaining all ones. And what does it start with? It starts with the 9 in the first position. Then how will row 9 be? It will start with 9, 1 1 1 1 1 1 1 1. Then it will have 1 9, 1 1 1 1 1 1 1. The 9 keeps on moving. We're talking about the last number in the 9th row. Where will it be? Quite easy. 8 ones and then ending with a 9. It's a 9-digit number, and the 9 has gone all the way from the first portion to the last portion. We're worried about the 45th digit, which will happen to be the 45th number, which will happen to be the last number in the 9th row, or the last number in the 9th row which has only 1 9 and 8 ones. So the 9 has to be in the last place, units place. So it is 8 ones ending with a 9. Beautiful question. You don't need to know any funda. They do it methodically. These numbers you should be able to pick, they're called something. I want you to find out what they are called. What is the name of numbers like 1, 3, 6, 10, 15, 21, 28, 36, 45, 55, those numbers. How do you find them? Is there a formula to it? Is there a very interesting way of remembering the formula? What is the specific title given to those numbers? I want you to find all of that, because this number has got to be your friend, this set of numbers. You see a 45, you should know the sum of all numbers from 1 to 9. The more comfortable you get with that, the simpler exams like this is going to become. So you're going to learn funda approaches, but you've got to get your mind to become friendly with numbers. You should be able to say, oh, 81 is 3 into 3 into 3 into 3. 729, I know that, 9 cube, I know that. 343, that is 7 into 7 into 7. 1024, that is 2 multiplied with itself 10 times. These numbers should hold more significance. You're going to see them more frequently, fairly frequently whenever you take exams. So keep that in mind. Beautiful question, 8 ones and a 9. That's what it ends with. Try this one. I'm just trying to keep one eye on the chat. The positive integers a, b satisfy 23a equals 32b. Can a plus b be a prime number? Justify your answer. All of these questions, how many of these will be prime numbers? Can it ever be prime? What happens? What are the different ways of having a plus b? What can you say about the property for a plus b? There are several possibilities. It's a beautiful idea to say, okay, there are lots of possibilities. I'm going to find one. I'm going to find one possibility, and then I'll work from there. Right? So a and b are positive integers such that 23 into a equals 32 into b. They're positive integers. I'm going to start with a very simple positive integer, 1. 23 into 1 is 32 into b, or b is 23 by 32. That doesn't work. A cannot be 1. If a is 1, b doesn't turn out to be an integer. A is 2, it will become 23 into 2, 46. That is 32 into b. Doesn't work. So think about it. 23 into 2, 32 into b. Cancel this, make this 16. But b is 23 by 16. Doesn't work. That's not an integer. Think about this. If you pause and think, this side, 23a, this is going to be a multiple of 23. This side is going to be a multiple of 32. Not rocket science, very regular stuff. 23 into something is a multiple of 23. 32 into something is a multiple of 32. So 23 into a has to be a multiple of 32. 32 into b has to be a multiple of 23. We're looking at it the other way around. 23 into a has to be multiple of 32. 32 into b has to be a multiple of 23. We'll worry about 32 into b later. 23 into a has to be a multiple of 32. 23 has nothing in common with 32. 23 is a prime number. 32 is 2 into 2 into 2 into 2 into 2. Nothing gets cancelled. What does that mean? If it has to be a multiple of 32, a has to be a multiple of 32. Straightforward. Or a could be 32 or 64 or 96, something like that. Let's put a equal to 32. So 23 into 32 equals 32 into b, or b is 23. Brilliant. We've got one value. Let's write down that value. We know 23a equals 32b. We know a equal to 23, b equal to 32 works. Brilliant. A is 23, b is 32. A plus b is 55. Can a plus b be a prime number, or this is not prime? I cannot say they cannot be a prime number. The one set of values for a and b that I've got, a plus b is not prime. Maybe the next one I have, a plus b will end up being prime. and we don't know that. Right? So A plus B right now is not prime. Now my mind is thinking maybe they can never be prime. So maybe I'll try to prove that, because especially this question is saying justify your answer. 23 into 32 equals 32 into 23. How will I get the next answer, next term for A and B? A has to be a multiple of 32. So A can be 64. 23 into 64. This is 32 into B. 64 by 32 is 2, or B is 46, or A is 64, B is 46. You add these two, we get 110. Think about these numbers, look at these numbers. A, I think I've written this down the other way around, I'm very sorry. A is 32, B is 23. A is 32, B is 23. A is 64, B is 46. This into 2, this into 2. Both sides become into 2 of whatever they were. They are both doubled. Or if A plus B added up to 55, next time they are adding up to 110. What will be the third possibility? A will be 23 into 32 into 3. This is A. B would be 32 into 23 into 3. So A is 32, B is 23. A is 32 into 2, B is 23 into 2. A is 33 into 3, B is 23 into 3. 32 into 4, 23 into 4. Or the total will either be 55 or 55 into 2, 55 into 3, 55 into 4, 55 into 5, 55 into 6, and so on. 55 is not prime. Any multiple of 55 cannot be prime, or none of these numbers be prime. Can A and B be a prime number? No, they cannot be, because A plus B will always be a multiple of 55, and 55 is not prime. So 55 into 1, 55 into 2, 55 into 3, 55 into 4, 55 into 9000, none of those numbers can be prime. Or A plus B can never be a prime. Justification, because A plus B will always be a multiple of 55. Good question. Try this one. There are 20 cities in a country. Each pair of cities is connected by an air route. How many air routes are there? Lovely. There are 20 cities. So there are 3 or 4, I'll say A, B, C, A, B, C, D. There are 20. It becomes tough to remember. So I'm going to call it as city 1, city 2, city 3, city 4, all the way to city 20. Lovely. Each one of them, each pair of cities is connected by an air route. So C1, C5, there is an air route. C2, C9, there is an air route. C19, C20, there's an air route. C16, C11, there's an air route. You want to count how many air routes are there. We cannot simply randomly write down. Anytime you have any of these how many questions, you have to say, okay, let me write down a few. And then you have to say, I'm going to write down with a pattern, with a plan, with an approach, with some method for counting everything. So I'm going to say, I'm going to write everything from C1. C1, C2, C1, C3, C1, C4, C1, C5, C1, C6, all the way till C1, C20. So from C1, we have 19 routes. Why? C1, C2, C2, C1, C2, 3, 4, 5, 6, 7, 8, 9 till 20. Everything is connected from C1. 19 possible routes. From C2, what can we have? Think about it. C2, C3, C2, C4, C2, C5, I'll count all of that. C2, C1, I won't count that. Why will I not count that? Because C2, C1 has already been counted. It's like saying there is a route from Bombay to Chennai. I will count it as a Bombay-Chennai route. I cannot say there is a route from Bombay to Chennai and from Chennai to Bombay. C1, C3 is a route. C3, C1 is the same route. Likewise, C1, C2 I have counted. From C2, I won't count that. I'll count only the remaining 18 are there. From C3, how many will I count? 17 will be there. C4 to C20. From C4, how many are there? 16 will be there. C5 to C20. All the way C19, one root, C9, C19, C20. From C20, there are 0 roots. Why 0 roots? Because I have counted everything. Everything to C20 I have counted. So from C20 to something I don't need to count because I have counted all of this anyway. So what will be total air roots? How many are there? Now all I have to do, add up all of them. Add up all numbers, natural numbers from 1 to 19. This is tricky. How do I add up all numbers from 1 to 19? Into 1, 2, 3, 4, 5, 6, 7, 8, 9. Take time. What do? I take 1, I combine it with 19, I get 20. I take 18 and 2, that's 20. 17 and 3, that is 20. So 1 and 19, 2 and 18, 3 and 17, 4 and 16, all of these add up to 20. All the way till what? 9 and 11. 9 plus 11 is 20. This is 20, 20, 20. Finally, there is a 10 as well at the end of it. So what will be my total? 20 into 9 plus this 10. 180 plus 10, which is 190. And so there's a beautiful formula for this. I'm going to give you that formula also. Whenever you're adding natural numbers, 1, 2, 3, all the way till n, sum of all natural numbers till n into n plus 1 by 2. Sum of all natural numbers till 19 into 20 divided by 2. N into n plus 1 divided by 2. N is 19. I'm adding all natural numbers till 19. 19 into 19 plus 1. 19 into 20 by 2. Sum of all natural numbers till n into n plus 1 by 2. Brilliant, we've done this. So I'm going to think about why does this formula hold good. It's a brilliant idea. What we're doing here, effectively writing in pairs. And so if you're adding 1, 2, 3, all the way till n, you add these two, you'll get n plus 1. You add this and the number before that. Sum of those two will be n plus 1. Why? From 1 to 2, I add 1. From n to n minus 1, I subtract 1. And 1 plus n is n plus 1. I add 1, subtract 1, add 1, subtract 1, add 1, subtract 1. My total cannot change. Each pair adds up to n plus 1. How many such pairs are there? Totally n numbers. N by 2 pairs will be there. N by 2 to n plus 1. I know what you're thinking. I know exactly what you're thinking. See, I'm also smart. You're thinking this will not work when n is even. This will not work when n is odd. How can there be n by 2 pairs? If I add all numbers till 17, I cannot say there will be 17 by 2 pairs. But the formula still works. I want you to figure out why the formula works. How does it work when there are an odd number of numbers? Think about that. Formula definitely works. Now this question I'm going to do slightly differently. Same approach. C1, C2, C3, all the way till C20. I'm going to say from C1 there are 19 roots. From C1 I can go to 19 different cities, 19 roots, done. From C2 there are 19 roots. From C2 I can go to other 19 cities, 19 roots. From C3 there are 19 roots. From C20 there are 19 roots. Why should I count C1, C2 only as part of C1? I'll count it as C1, C2 and I'll count it from part of C2. Suppose you are listing down all the cities. You cannot say everybody can go to the final city. You can't go from the final city to anywhere. You can. Why should we discriminate against C20? From each city there are 19 routes. But now think about it. From C1 to C5, you would have counted that route. That same route, you would have counted from C5 to C1 also. Every route you count twice when we do this method. The total number of things is 19 into 20. This total number double counts everything. If I take one route C5, C7, I'll count it as C5, C7 and as C7, C5. I'm counting Bombay, Chennai and Chennai, Bombay. Bangalore, Delhi and Delhi, Bangalore. I shouldn't. So what do? I know I'm double counting. How do I adjust for it? I'll say, okay, it's not 19 into 20. It's 19 into 2 by 2. I doubled everything. I'll divide by 2. Or this is 19 into 10, 100. Lovely. So there are different ways of thinking about this. One is formulaic, one is the simple approach that we saw. Other is this approach where we double count and then divide by 2. Lovely. I'm going to go to the next question. Ram checks his purse and finds that he can buy an apple and 3 oranges, or 2 apples for the money he has. Easy question. There have been oranges also here. I wouldn't have liked the question. You can, now this part is easy. 1 apple and 3 oranges you can buy. 3 oranges, I'm going to write as otherwise it looks like 30. And so 1 apple and 3 oranges you can buy, or 2 apples for the money he has. He can either buy this or he can buy 2 apples. 1 apple and 3 oranges or 2 apples. Straight away something is popping out of this. From here, if he has 1 apple, money to buy 1 apple, he can either buy the second apple or he can buy 3 oranges, or the cost of 1 apple, nothing but the cost of 3 oranges. Done. One very simple equation. Whatever it costs to buy 1 apple, for that price you can buy 3 oranges. Lovely. Now let's go to the rest of this. From the same shop, Bhim buys 2 apples and 2 oranges for rupees 16. 2 apples plus 2 oranges for rupees 16. Lovely. We know 1 apple costs the same as 3 oranges. He's buying 2 apples. That will cost the same as 3 oranges plus 3 oranges. Like 1 apple he can replace with 3 oranges plus 2 oranges. That costs rupees 16. Or 3 plus 3 plus 2, 8 oranges cost 16. Or cost of 1 orange is 2 rupees. 16 by 8 is 2. 1 orange cost 2 rupees. An apple costs same as 3 oranges, or 1 apple costs 6 rupees. Orange costs 2 rupees. 3 into 2, 6 rupees. Lovely. Now let's go further. How much should I pay when I buy 3 apples and 2 oranges from the same shop? Oh, lovely. 3 apples plus 2 oranges. 1 apple costs rupees 6. This will cost 3 into 6. 1 orange costs rupees 2. This will cost 2 into 2. 3 into 6 is 18. 2 into 2 is 4. 18 plus 4 is 22, or it will cost 22 rupees. This is equation manipulation. So we'll write linear equations and manipulate them. You'll find several forms of algebraic manipulation, and you'll learn that more and more when you go to higher classes. But before that, you can just sense patterns even without doing all that. And 2 apples cost something, 1 apple and 3 oranges cost something else. Straight away you know 1 apple costs the same as 3 oranges, and then you're done after that. Try this one. 2 ants start at A and walk at the same speed. One along the square of sides 3 cm, and the other along the rectangle with dimensions 3 by 6 as shown in the figure. The minimum distance anyone must cover before they meet again. They start at A. One ant goes like this, perhaps. Another ant goes like this. This keeps going around in this square. This keeps going around in this rectangle. And so this measures 3, 3, 3, 3. This measures 3, 6, 3, 6. First of all, the first idea is we want to know how much anyone must cover, the minimum distance anyone must cover before they meet again. They meet again somewhere. Think about where they can meet. Between this square and this rectangle, there's only one common point at this point A. So they should, if at all they meet, they should meet at A. And so they cannot meet at any other place. If they're meeting, they must meet at A. Lovely. So let's think about, after traveling how many centimeters will either of them come to A? And so this one, the first ant, this ant will come there after covering 12 centimeters. This one will come there after covering 3 plus 6, 9, 3 plus 6, 9, 18 centimeters. Lovely. So when this one does 12 centimeters, the second one would have done 12 centimeters and be only at this point. Then by the time the second ant comes here, the first ant would have gone till here. So they keep on traveling, but at some point of time, both of them should be here. We want to think about that distance that each of them has to travel such that both of them happen to be at A. Now I'm going to forget about both of them. I'm going to track ant 1 alone. Ant 1 will be at the point A after he has traveled 12 centimeters. That is clear. And then when will be the next time he will be at A? After he has traveled 24. After he has traveled 36. One more round, one more round, one more round, and so on. So 36, 48, 60, 72. Each of those 12 centimeter additional bits, ant A1 will be here. Now let's think about ant A2. Very simple. After 18, he'll be here. After 36, he'll be here. After 54, he'll be here. After 72, he'll be here. Plus 18, plus 18, plus 18. Right? Now let's think about this. They're both traveling at the same speed. So they'll be at A if they have traveled at the same distance at some point of time. At any point of time, there is a number common between this list and this list. We are through. Or we are looking for a multiple of 12 to happen to be a multiple of 18. Or we are looking for a common multiple of 12 and 18. Or we are looking for the least common multiple of 12 and 18 because you want to find the minimum distance they have traveled. That is 36. Or after 36 centimeters, this fellow would have done 3 rounds, this fellow would have done 2 rounds, and both will happen to be A, at A. So if both have traveled 36 centimeters, they'll meet at point A. Lovely. Let's do the next one. Oh, this is a very interesting question. Probably slightly challenging as well. Give it a go. Some of you guys are saying you've done area of the square. This guy is walking along. He's not sweeping the floor. Why would you worry about area? Fine. Silly error. You should be harsh on yourself. You should say, look, if I'm sweeping, mopping, or you should say, look, you should sweep the floor of the house as compensation. Then tell yourself, look, this will remind me every time that I think about area that I have to be doing this. So you're going around, moving in one dimension, then you're thinking about perimeter. If you're mopping, if you're wiping, if you're laying the floor, if you're painting a surface, then you're thinking about area. And so be very careful. You get an idea right and you get some detail wrong, it's a crime. Because the tougher and tougher exams you write, it's going to be really tough to get the idea right. And then you get the idea right and you go all the way and you get some answer wrong, that will be a crime. In your regular school exams, for say 50 marks and you have 23 questions, you'll probably know the method for 22 of them. You'll have to figure out a little bit for the 23rd. So it's not an issue. You'll do something quickly, and for 23rd question, you'll spend some more time, get that right. Maybe you have made some careless mistake, you get 48 out of 50. You feel slightly disappointed, but you're happy. But in an exam like this, the 20 questions, chances are, straight away you know the approach only for 8. And you make some mistake in 3 of them, you end up with a below par score. So be very careful, you can't afford to make mistakes. Right? Amit, Bharat, Chitra and Deepa are friends, and one among them committed a crime. They made the following statements. If only one of the statements is true, find who was guilty. A, B, C, D. Luckily the names are very friendly. Only one of them is true. These questions are very simple for approach wise. I'm going to say, let me assume only Amit is true. Only what Amit is saying is true. Let me see if these statements are consistent. Then I'll be good. Then I'll go to B, then I'll go to C, then I'll go to D. And first up, I'm going to say, Amit speaks the truth. B, C, D all lie. Amit says Bharat did it. That means Bharat has committed the crime. Lovely. So Bharat has committed the crime. Bharat says Deepa did it. That is not true. Bharat has committed the crime. So what B is saying is false. That works. C says, I did not do it. That is also true. Because what Amit is saying is right. That means Bharat has committed the crime. Then Chitra says, I did not do it. That is also true. If A were true, C will also be true. Therefore, A cannot be true. Very simple. If A were true, then C will also have to be true. So if A is true, we cannot have a scenario where only A is true. That is out. Life is simple. A being the only person saying the truth has been eliminated. Let's move to B. Bharat says Deepa did it. And B is true. The crime committed by Deepa. Now let's go step by step. A is saying Bharat did it. So A statement is false. Lovely. That is consistent. Chitra is saying I did not do it. It happens to be true. Chitra is saying she did not do it. And Bharat is saying Deepa did it. So if Deepa did it and the Bharat statement were true, Chitra's statement would also be true. So B alone speaking the truth is also ruled out. So only person speaking the truth cannot be A, cannot be B. Let's move to C. Chitra says I did not do it. And so Chitra says I did not do it. We're assuming only this is true. Go to A. Bharat did it. That has to be false. So Chitra did not do it. Bharat also did not do it. So the crime not committed by Chitra, not committed by Bharat either. Bharat is saying Deepa did it. That should also be not true. Chitra is saying she did not do it. Just what Chitra alone is speaking the truth. That's what we are thinking about right now. That means A, B and D should have lied. If A has lied, that means Bharat did not commit the crime. If B has lied, that means Deepa did not commit the crime. Chitra is anyway saying I did not do it. C did not commit the crime, or the crime was committed by Deepa. So far so good. If the crime had been committed by Deepa, then statement 1 would be not true. Statement 2, Deepa did it would be true. Oh, I'm getting something wrong. So I'm going to go over this one more time. This idea of Chitra speaking the truth. So I'm going to go over this whole process all over again. And so Chitra alone speaks the truth. It means Chitra, we're assuming he speaks the truth. A is saying Bharat did it. That should be wrong. So Bharat did not commit the crime. B is saying Deepa did it. That should also be false. So Deepa did not commit the crime. C is saying I did not do it. That should be true. That means C also did not commit the crime. I mean, by elimination, A committed the crime. If only what C is saying is true, for the first 3 statements, we can infer that A committed the crime. Let's look at the final statement. Bharat lied when he said, I did it. Bharat lied when he said, I did it. Is that statement true? Bharat is saying Bharat did it. But Bharat did not do it. Bharat says Deepa did it. Deepa saying Bharat lied when he said I did it. Yep, ends up being true. If C were true, D would also be true. Very interesting. If C were true, then D would also be true. See, Chitra is saying I did not do it. That means Chitra did not commit the crime. Other 3 should have lied. Bharat did it. That should be wrong. That means Bharat did not do it. Deepa did it. That should be wrong. That means Deepa should not have done it. This is true. B, D, C have been eliminated. From the first 3 statements, we can infer that A committed the crime. Now let's look at statement 4 from Deepa. Bharat lied when he said I did it. Bharat lied. That is true. Bharat has lied. So this statement becomes true. Or if C is true, D also happens to be true. So C alone being true can be ruled out. Now let's come to the final thing. Last one. We are left with the possibility that only what D said is true. Bharat lied when he said, I did it. So Bharat lied when he said, I did it. That means Deepa but what Bharat has said is not true. That means Deepa did not commit the crime. Because if Deepa had committed the crime, Bharat, when Bharat lied when he said, I did it. That means Deepa did not commit the crime. Because if Deepa had committed the crime, what Bharat says would have been true. So, lovely. So this statement alone is true. From that we know that Deepa did not commit the crime. Statement 1 should be false. From that we know Bharat did not commit the crime. Statement 2 should be false. From that we know Deepa did not commit the crime. Statement C should be false. Statement C, Chitra is saying I did not do it. That is false. That means Chitra committed the crime or Chitra commits the crime. The only possibility that is true. So the scenario we have is only statement that is true. This one. The person who committed the crime is Chitra. Chitra committed the crime. Bharat did it. This is false. Deepa did it. This is false. I did not do it. This is false. Bharat lied when he said I did it. True. So Chitra committing the crime and only Deepa being the person speaking the truth, that works, that ticks all the boxes. Or find out who was guilty, Chitra was guilty. Lovely question, really tough question. Some of these reasoning questions could be very interesting, but from an exam point of view, you probably got to say, okay, I'll come to this, but not straight away because it's going to take some time. You're going to worry about which one statement is true, if this is true, that should not be true, all of those things. So when you, from an exam context, when you get a question like this, you say, look, I'll come, but I'm not going to do this straight away. I'll do it after I try out some of the other questions. Lovely talking with you guys. So it was good fun discussing these questions. I'm going to catch up with you again on Thursday, 2 days time. So as ever, you can check out the description. You will find the link where you can download the paper from. So go to PiVerb.com/AMTI. You can get the download the PDF for the next class's discussion. Try that set of questions before the class. Let's have some fun. Yes.